And of course, the other reason why we're interested is because some of us believe in the singularity, and reaching that obviously is quite important. People used to sort of predict it was about 2030, and in fact there was some that changed their name, FM 2030, because this was sort of like the commonly accepted date in my hand. Well, more recently I've noticed they're now saying it's 2045. So in about 20 years, it slipped by about 15 years, which is quite worrying. If it carries on slipping at that rate, none of us will be alive when it happens. So slowing aging is quite important, and we need to do it now before the singularity arrives. And the other thing is you need to reach the singularity in good health, because you never know what it might be like. Even if it's a good scenario, which I think it probably will be, you still need to be in good health. If you're old, you might not be flexible enough to adapt in society, or the initial medical procedures might not be applicable to someone in a really bad state of health. So why have people become more interested in it now? So I think it's because immortality is much more credible now than it was 20 or 30 years ago. I mean, you couldn't seriously talk about immortality 30 years ago. Everyone would just think you were completely insane. Now you even see mainstream doctors talking about it, saying, and normally it's couched in terms of now, well, yes, our children will probably live forever, or our grandchildren will. And to miss out on that would be quite awful. And so now a lot of people practice CR, which they never used to either, because it's obviously an unpleasant thing to sort of do, and it's quite difficult, and it's too difficult for me. I mean, I wouldn't try it. But since you've got a chance for immortality, it's a chance worth taking, what people figure. But are there any easier options? So first of all, let's see why we age. See how easy it is. So I'll just list a couple of theories, some theories that people have come up through over the years. And we'll start with the most ridiculous ones. So people used to often think, and it's probably still a popular conception or misconception, is that aging is somehow necessary for the species to survive. You need to get rid of the old individuals, or the newer individuals, and to take their place. Somehow aging has evolved so that species can evolve. Now, we don't really think that's very sensible nowadays, because species selection is a pretty discredited idea ever since Dawkins came up with the selfish gene concept. Many things that people used to think were products of species selection, we now understand as being a result of selfish gene activity. So we don't really take this theory very seriously anymore. It used to be quite popular, I think, and it's probably still what the public believe, but not scientific theory. Another one is that it's just the rate of aging. The faster you live, the faster your metabolism is, the quicker you age. Now, so small animals normally age quite quickly because they have very high metabolic rates. A large animal has a much lower metabolic rate normally. The reason why small animals have high metabolic rates is because they lose heat. They've got a much higher surface area to volume ratio. So simply to keep warm, they have to burn many more calories per unit per gram of tissue. And so you get a rough, people came up with this rough notion that total number of heartbeats or an animal's life is roughly the same for all mammals. Or you could say total number of calories burned might be the same per gram of tissue or something like that. Unfortunately, birds violate this rule completely. They're normally quite small animals, have very high metabolic rates, and yet they live a very long time relative to an animal the same size. So perhaps it only works for mammals, but unfortunately people are also the exception. We live much longer than we should do by the same metric. I think it's about 3 times as long using this as you would expect. So obviously this theory doesn't work. Another one is that we just wear out. Everything we do, we slowly degrade ourselves, and eventually you just get ground down and you drop dead. Quite an old theory, and then it was updated a bit later on to include ideas about protein synthesis. DNA degrades, and also the mechanism for producing proteins, ribosomes, they also degrade. So slowly, as you get older, your proteins malfunction more and more, and that contributes to dying. So that's sort of a half-credible theory. There's certainly some truth to that. Developmental theories, the idea there is that aging is just like a stage in development, and everyone grows up, and then you grow old, and then you die. But the trouble is, not everyone grows up, but they still die. Whereas we don't see the converse. We don't see people that grow up but don't grow old. But if aging was a developmental process, you'd expect for some people it wouldn't work, so it wouldn't happen. But that doesn't happen. That's very forward, and that's the example in physicist or Peter Pan syndrome. Quite rare, but these people do exist. And
sorry, what's Peter Pan syndrome?
It's where you never become sexually mature, and you, for some reason, there are a number of different causes, but basically at some point your development just halts. And yet these people will still grow old. We never see anyone where the growing old development stage does not happen, so therefore it isn't a stage in development. But the other big problem with it, why would evolution ever bother to build in a developmental stage of old age? Because most animals in the wild never reach old age. They die beforehand, they get eaten. So evolution would be indifferent to old age. It doesn't have to program it in to kill us, even if it wanted to, which of course it doesn't. Because life will already do that.
Unless you're an elephant.
Well, with elephants, they've only got about 7 sets of teeth, I think. So when the last set of teeth fall out, they just starve to death. Now that's probably that's a reasonable. That is a developmental thing. But whether you call that old age, I'm not quite sure. It'd be quite interesting to see if to fit an elephant with a sort of artificial set of dentures to see how long it will live after that. But no one's done that yet, as far as I know. So here's another one, disposable soma theory. Now this is quite a credible theory, and it's the mainstream one today. And the idea here is that all evolution cares about is our genes. That's what's been selected for. So our bodies, or soma, are quite disposable. And that's what evolution invests its resources in. Once you're past reproductive age, then you just degrade. And I think we can all testify to that if we're old enough. The other thing is that some genes often have more than one effect. That's what we mean by pleiotropy. An antagonistic pleiotropy is when a gene that has a good effect when you're young has a deleterious effect when you're old. And things like the immune system being very strong. You need a strong immune system when you're young, but often when you're old, various autoimmune effects, they might give you arthritis. Now that's part of this idea. Evolution just doesn't care about removing those genes, because once you've reproduced, then your soma is disposable. It doesn't really care. And this is pretty much what people believe nowadays. This is what I think most working gerontologists adopt, this hypothesis. And it makes predictions. Creatures without a germ-soma division will not age, according to this. And that's what you find in Hydra. Any part of a Hydra is capable of becoming a new organism. And if you feed them adequately, that indeed is what happens. If they've got plenty of food, they just bud off. That's the easiest way for them to reproduce. And they can just carry on doing that indefinitely. They've got total regeneration from any wounds. Another prediction is that...
so you're saying the hydras live forever then?
Yes, that's right. They are immortal. Yes. I mean, what normally happens is that seasonally they run out of food, and then they start to shut down and reproduce sexually. But as long as they have adequate food, they basically will just function forever.
Does that mean that all hydra are one?
Well, no,
is there just one?
No.